Hi, today you will learn why measuring the magnetic flux density in the air gap is the first thing you should do if you have generator vibrations. If you've seen any of my previous videos, you know that I have a thing for large generators and magnetic flux measurements. The first thing is obvious, loving large generators. You must agree, they're just magnificent. Regarding magnetic flux measurements, on the other hand, you might be sitting there and think, I've done fine so far without any flux measurements. Why should I start now? And that is why flux measurements is the subject of this video. But let's start with the more basic questions. Why do we take generator measurements? The answer is that we measure our generators to make better informed decisions. And better informed decisions reduce costs and increase the uptime of your generators. Knowledge about the magnetic flux will also make you look good when investigating faulty generators. The more information you have, the less often you have to say, I don't know. I will show you some of the things you can learn from flux measurements. This knowledge will help you make better maintenance and investment decisions, which will increase the lifespan of your generator. If your generator behaves like this, you want to know why. The flux graphs usually contain interesting clues, and this holds true even if the root cause of the problem isn't magnetic. Because problems not related to the field winding often also result in asymmetric flux density, even if the rotor and the field winding are perfect. And here I'll show you two production machines with examples of this. If you get a measurement that looks like this, you have a whirling rotor, and the fundamental problem is mechanical and most likely stemming from the shaft, bearing and rotor system. If, on the other hand, your measurement looks like the one depicted in this graph, you have a serious problem with the flux from two of the poles. And this problem relates to the field winding, and it reveals an electromagnetic problem with two of the poles on the rotor. One of our clients found out they had an oval rotor when they were making measurements to investigate another problem. Now, if you're into generators, you already know that the magnetic flux generated by the rotor is what induces the voltage in the stator coils, and that's the whole idea of the generator. But an asymmetric flux density can also create vibrations on the rotor, in the shaft, and in the stator. Yes, in the stator. Because unlike a mass imbalance, which mainly affects the rotating parts and the bearings, a magnetic imbalance pulls at the stator and causes it to vibrate. These vibrations contribute to the aging of the stator frame, core, and its winding. Here's another example. But if you have a graph that looks like this, the vibrations probably don't have a magnetic origin. You see how smooth the graph is? Many speculations regarding vibrations concern the magnetization, and until you know what the flux density in the graph looks like, they remain just that, speculations. Having a graph of the flux in your hands is a way of avoiding having to say, I don't know. If the graph looks good, and the investigation can focus on other causes of the vibrations. With flux measurements, you can find the cause of vibrations faster, often eliminate the magnetization from the investigation, avoid having to say, I don't know, and sleep better. And there are also other reasons to measure the flux density. You can avoid disputes regarding whether the field winding was affected during another activity on the rotor. Measurements before and after work will show whether the field winding was affected. If you're a service provider, measuring magnetic flux density can reveal problems with the rotor that you can help the owner with before they become critical. If you're an owner, knowledge about the flux density will improve your asset risk management.